Hi, everyone. Welcome to week two of the Synergix conference. This session is business considerations when migrating Synergy apps to the cloud. My name is Phil Bratt. I'm joined by our presenter, Synergix Software Development Manager, Tim Bogus. Tim has a professional background in software engineering and technical leadership. After graduating with a BS in computer science, Tim joined the Synergix QA team, moved to IS, and then is spearheading the DevOps processes. He's developed his expertise at multiple companies, specializing in .NET, Microsoft Power Platform, and Azure. As always, there will be time for a QA after the presentation. And in the meantime, you can post questions to our chat section and the QA section in the chat, of course. And if for any technical issues, please contact the classes at synergix.com. This session is being recorded.
Hello, I'm Tim Bogus, a software development manager at Synergix. I have a software engineering and technical consulting background, largely based around cloud applications. During my career, I've taken ownership of standardizing cloud infrastructure and have facilitated application migrations to cloud-based environments. I also have a background working with Synergy as the current lead of the Synergy DBL integration team. Today, I would like to help you bridge the gap in business considerations that must be considered before migrating Synergy applications to the cloud. So, what business considerations are we going to discuss today? There will be three main categories. First, we will go over the high-level benefits of cloud computing. I like to categorize these benefits into three key areas: efficiency, flexibility, and minimizing risk. Next, we will step into what is involved in a cloud migration. What migration strategies are available? What cloud models have other businesses adopted? What will the level of effort be to make a cloud migration happen for my Synergy application? These migration factors are all important considerations to make before committing to your cloud migration. Finally, once a business migrates their application to the cloud, how do they maximize the value? This last section will cover replatforming and refactoring to take advantage of platform optimizations available in the cloud for your application. The end goal would be moving towards a more automated DevOps deployment model with infrastructure as code in place that enables you to take advantage of orchestration frameworks like Kubernetes or Docker Swarm or Redshift that will allow you to effortlessly spin up and scale out your application. Now, before we jump in, what is cloud computing? Let's go over the basics with an analogy. Cloud computing is like plugging into a central power grid instead of generating your own power. You can consume exactly the power you need without worry of over or under production. You do not have to build or maintain your own hardware like solar panels, storage batteries, or generators. You do not have to worry about your hardware becoming compromised or outdated. You get to take advantage of a commercial platform leveraging the latest and most efficient hardware technologies. If you want to have solar panels and be connected to the grid, you still can with a hybrid approach. Connecting to the grid gives you the flexibility and access to the most efficient sources of power, while not locking you out of any customizations you need with your local setup. So let's tie that analogy back into cloud computing from the grid. Cloud computing gives you on-demand delivery of your IT resources. This is all done over the internet, which means you can access your IT resources from anywhere with the right credentials, just like you access your personal email. Instead of having to buy, own, and maintain physical servers and data centers, you get direct as-needed access to IT services, from computing power to physical storage to databases. Because you're doing this on an as-needed basis, you're only paying as you go. No more large upfront investment. This keeps your prices stable month over month and based on your exact consumption needs, without limiting your ability to rapidly scale up or scale down as needed. Now, I do want to be clear. This presentation will be specifically focusing on the infrastructure as a service, or IaaS variant of cloud computing. This is specifically the hardware resources being provided as an ongoing service from a cloud computing provider. You may also see terms like platform as a service or PaaS and software as a service or SaaS or SaaS. But this is specifically for end user applications or platforms to build applications that are already managed for you. When migrating an existing Synergy application to the cloud, the best place to start would be with infrastructure as a service, replacing your in-house management of virtualization, servers, storage, and networking. After your Synergy applications are migrated to an infrastructure as a service cloud computing provider, you are now enabled to re-platform and refactor to take advantage of other platforms as a service or software as a service integrations, utilizing the cloud computing provider you chose. So what cloud computing providers are out there? There are three big infrastructure as a service providers dominating the cloud computing market. We have Amazon Web Services, Microsoft Azure, and Google Cloud Platform. There are other providers out there as well, including IBM Cloud, Alibaba Cloud, and Rackspace that can help serve more specialized needs, like for specific private or hybrid cloud environments. More on that a little later. Out of the big three though, AWS has captured the largest market share, followed by Microsoft Azure and then Google Cloud Platform. Typically, due to the increased popularity, one of the big three will be your safest bet here, due to larger ecosystems of supporting tooling and specialists. When choosing a cloud provider, it is important to evaluate several criteria, including cloud security, cloud compliance, architecture, manageability, support, and costs. You may also want to utilize specific container capabilities as you containerize your Synergy applications, as the available capabilities do vary across different cloud providers. For example, Azure Kubernetes Service, or AKS, is available on Microsoft Azure, and the Elastic Container Service, or ECS, is available on AWS. These also have different supporting tools for containerization, available on each provider, including persistent volumes that support read-write-many with different specifications. Please take a close look at each cloud provider's software licensing agreements and capabilities before making your decision. You can also take a more generic route to diversify into multiple cloud providers or switch around if needed. Now that we've gone over a high-level overview of cloud computing and some of the big three providers, let's hone in on the benefits in migrating your Synergy applications. As I mentioned earlier, I personally like to break the many benefits of cloud computing down into three big categories. Flexibility, how cloud computing enables maintaining your applications to be more accessible and scalable. Efficiency, how cloud computing provides you the most value out of your applications. And reducing risk, how cloud computing improves security and enables innovation. Let's now jump into all three of these categories. So here are the benefits of the flexibility of being on a shared cloud provider grid over local on-premises hardware. Cloud computing is location-independent computing. Shared servers provide resources on demand wherever you may need them to give the best end-user experience with the lowest latency to customers. You can spin up new servers to target users geographically in any region you need, whenever you need. If you no longer need a server in a specific region, you can tear it down or move it elsewhere at a press of a button. Cloud infrastructure scales on demand to support fluctuating workloads. If you need a new server, you can spin it up instantly with your pre-configured application settings. If you need to scale back, you can tear it down just as quickly. All of this demand can be pay as you go. You no longer need to invest significant funding upfront to fund a new project or upgrade an existing infrastructure. The cost gets spread out evenly and allocated based on your exact usage. You don't have to worry about not buying enough hardware or buying too much hardware. Pay as you go sets you up for the ultimate cost control. Your cost now can be based on your monthly utilization and be broken down to see exactly what is consuming the highest cost. This lets you prioritize the most valuable areas to improve costs over time while keeping your costs stable and controlled. Accessibility lets you manage your infrastructure from anywhere. As most cloud providers are internet accessible, your staff could support the hardware backing your Synergy applications remotely from anywhere without needing direct access to the on-premises hardware or a VPN. Efficiency. How does adding another layer around the base hardware make you more efficient? Well, you get to reduce your total IT cost. You now have cloud providers managing those base infrastructure as a service IT resources for you. With public cloud computing, you are sharing the physical hardware with other companies at a massive scale. This significantly reduces the overall cost of management, and even with the extra service provider layer, the total costs should come way down, especially with only paying for the exact IT resources that you need at a given time. You no longer have to worry about your on-premises hardware refresh cycle policy. The industry best practice is to refresh all of your on-premises hardware at least every 3 years. The cost of owning new on-premises hardware adds up very quickly if you follow the industry standards. If you don't, then you're accepting a higher risk of hardware failure and less performance efficiency over time. Now, beyond the lower IT cost, your cloud provider is also managing the hardware refresh cycle for you beyond these industry standards. So you are staying with the latest and greatest. The flexibility of accessibility ultimately enables more efficient collaboration as well. Now, you don't need all of your employees to be physically on premises or through a VPN to access shared resources. They can collaborate as they see fit. Being internet accessible enables your employees to work together on solving problems from anywhere. This is ideal to be efficient in the post-COVID remote working world. Agile deployment of your Synergy applications is one step closer now by moving to a cloud-based application environment. Being accessible to the internet enables easier integrations of agile DevOps automation processes, including continuous integration and deployment. Replatforming on the cloud to stateless servers enables more consistent automation. Being in a major cloud provider's ecosystem also gives you more direct access to pre-built tooling to manage your infrastructure and deployments of software. After you rehost your application on a cloud provider, you can slowly make the transition to replatform more of your applications to take advantage of features and integrations in the cloud provider's ecosystem. We will go more in depth on replatforming and refactoring your applications to maximize efficiency and value a little bit later in this presentation. Now, when hosting primarily on premises, you're exposing yourself to unnecessary risk that can be optimized or even offloaded by working with a cloud provider. Disaster recovery plans, or DRPs, can be fully automated in a cloud environment, even with a pre-built tooling available, such as the Disaster Recovery as a Service, or DRaaS tool. These DRaaS tools not only back up all of your data, but also your infrastructure by providing all the orchestration you need to regain immediate access and functionality. This minimizes any potential downtime, and although there may be less need to resort to your custom disaster recovery plan in the first place, as the service licensing agreements for cloud providers like Microsoft Azure, they guarantee upwards of 99.9% reliability with often built-in redundancy. For example, Microsoft Azure GeoZone Redundant Storage, or GZRS, synchronizes your data across 3 Azure availability zones to ensure high availability even during a regional outage. The accessibility and resiliency of a cloud-based computing environment fits right into a healthy business continuity plan, or BCP, as the infrastructure and data can be accessed from anywhere, easily backed up and recovered, or configured for redundancy. Your business can minimize or even eliminate downtime to ensure continuity. Even if you prefer an already configured on-premises solution for your applications, a cloud deployment can be configured for failover during local on-premises outages, if you experience higher than expected traffic, or even a denial of service attack. Your cloud provider can help mitigate the attack or scale out resources to handle the workload without you losing any availability. A key component of the overall security for your IT systems is the security of the physical infrastructure and housing facilities. Major cloud providers have top-of-the-line security standards that withstand constant audits and reviews. These standards include physical perimeter security, access entry controls, and secure facilities. Typically, these data centers are built to withstand natural disasters such as earthquakes or fires. They also follow best practices for disposal of old cycled hardware to ensure data security. Are you following these best practices? The cloud providers are also using the latest hardware technology. Being constantly up to date ensures there are no known vulnerabilities that attackers could use. As we discussed in the efficiency section, the cloud providers are also following best practices around hardware refresh cycles. This is ensuring you are on the optimal hardware technology with less risk of unexpected failure. You are now sharing the legal responsibility with the cloud provider. They are the ones responsible if someone gets physical access or the cloud is compromised. The cloud provider has full responsibility for the security of the cloud infrastructure. Your responsibility is now just the security on the cloud. Infrastructure with policies such as, let's say, user management. But they are responsible for the cloud itself. What I really appreciate about the flexibility and efficiency of cloud computing is how it sets up your development efforts to fail fast. You can commit resources quickly and tear them down just as quickly if you need to pivot another direction. You have clear traceability for your infrastructure costs to see what is working best and when you need to pull the plug. This encourages innovation through risk-taking. You no longer have to purchase hardware upfront that you'll still own and must manage regardless of the corresponding projects being downscaled. It is riskier to buy hardware. What is riskier? Buying hardware and software to create hundreds of virtual machines, or simply renting them based on runtime, and then spinning them up or down immediately as needed. Now that we've reviewed the basics of cloud computing and the benefits of a cloud migration, let's jump into high-level strategies of how to migrate your Synergy applications to the cloud. What migration strategies are available? What cloud models have other businesses adopted? And what will the level of effort be to make a cloud migration happen for my Synergy application? There are three primary legacy or classic to cloud transformation strategy options available for cloud migration. These options are not mutually exclusive. I would suggest beginning with rehosting, then replatforming, and eventually moving towards refactoring, although you could jump these stages as you see fit. Rehosting involves just lifting and shifting to an existing Synergy application to the cloud as is. You could rehost by spinning up virtual machines with similar hardware to your existing infrastructure, then redeploying your Synergy application on top of that. Rehosting is the most cost-effective upfront, as it requires the least amount of time and technical knowledge. This approach also avoids risk caused by tinkering with legacy code. There are some longer-term costs of this, as it's not quite as optimized as the other approaches. So I do suggest moving towards replatforming or refactoring as you continue forward. Replatforming is similar to rehosting, but instead of moving completely as is, you begin taking advantage of benefits from the cloud provider environment over time. This is the middle path to cloud migrations, between rehosting and refactoring. This would be a good opportunity to refine your build, test, and deployment processes for future automation improvements. Having these processes will enable you to tinker with legacy code with less risk. As you begin tinkering, you can start splitting your monolithic applications into more manageable services for future containerization and scaling. You can also start integrating other services into your application more effortlessly. Refactoring or re-architecting involves rewriting sections of your application codebase to better fit within the cloud environment. Refactoring is the highest cost and risk up front, but it enables you to fully take advantage of cloud features like automation and orchestration to maximize business value moving forward. To mitigate that risk up front, you can start with rehosting, moving to replatforming, and then finally refactoring to really get the best of both worlds here with the lowest upfront costs and the most value moving forward. Now, there are 4 cloud deployment models that businesses have adopted. All deployment model types manage scaling abstracted computing resources across a network. Every type also enables cloud computing workloads within that system. All cloud models also utilize operating systems, they manage platforms, and an application programming interface or API to manage the abstracted computing resources. You can leverage automation software across all types of cloud computing models to increase value. So what's the difference? Public clouds are created by infrastructure entirely owned by a cloud provider that typically run off premises, although there are some exceptions nowadays. Public cloud environments are partitioned across multiple tenants. You'll be sharing your infrastructure with others that help reduce overall cost. This category includes the big three: AWS, Microsoft Azure, and GCP. Private clouds are cloud environments dedicated to a single isolated customer. The key difference here over public clouds are the full isolation, greater networking control, and additional cost of not sharing infrastructure with other customers. Because you're not sharing that infrastructure, that's why you have a little bit more network control here. Private clouds can be hosted on premises, managed completely by a vendor at a remote data center, or dedicated as a singular partition under a large cloud provider like the big three. Now, the hybrid cloud model is a combination of the public and private cloud models. For example, you can primarily host your application on premises with a private cloud and use a public cloud for continuity failover if your private cloud has an outage. Requires scaling for higher than usual workloads, or to even target specific regions. Community cloud is similar to private cloud, but instead of a single tenant, there is a group of closely connected tenants. For example, the US government agencies may share their own cloud environment that requires specific security regulation standards. Community clouds can also be hosted by the big three. For example, Microsoft Azure has a government cloud that is FedRAMP compliant. There's also multi-cloud. It's not quite listed here as one of these four deployment model types, but it describes having a cloud model that leverages multiple providers regardless of the model. It's very similar to hybrid, but it includes multiple providers that could fall under the same model, such as using both AWS and Microsoft Azure for your public cloud. Multi-cloud is typically used primarily for redundancy to diversify for resiliency. So if one provider has an outage, then maybe the other provider will not. So what is the effort behind a cloud migration? A cloud migration can be broken down into multiple stages. First, there needs to be careful analysis done on the technical and business needs to determine the best route forward. Next, the migration scope is underway. The overall migration effort is impacted based on the volume of transfer data, specific configuration demands for your new environment, and the need for workload availability. It is recommended to configure the migration side by side with your existing deployment to ensure high availability. Once the configuration effort is completed and the data is transferred and accessible, rigorous testing should be performed before slotting in the migrated application. It would be ideal to improve automated testing to ensure a smooth transition. I actually recommend viewing our other presentations on unit testing Crusty Synergy code from Arif and Marty. The final phase is the support phase, where you should look forward to beginning to replatform your application to take advantage of cloud provider features while ensuring high availability. Maybe you're someone who happened to already jump ahead to refactoring. I would still suggest starting with rehosting and working your way forward to replatforming, but you can definitely jump ahead if you are extra eager. But this final support process needs to be frictionless to ensure continuity and overall migration success. So let's actually go more into detail here on what the costs look like behind this migration effort, all three phases. The new infrastructure on the cloud has many benefits, but it still needs to be paid for. It's not free. Typically, though, we're using the pay-as-you-go billing, as I mentioned earlier. There's little upfront cost, especially compared to physical hardware. This recurring cost will also start lower as you're testing your side-by-side migration until you ramp up based on appropriate end user demand. So that could offset some of the costs during the transition process. You will need administration staff to manage your cloud resources, but there are ways to maximize that cost as well. The cloud provider handles the physical infrastructure, but you will need technical resources to leverage the APIs for your cloud providers to maintain your application on the cloud. Although you're not responsible for the security of the cloud directly, you are responsible for the security on the cloud. So these resources should be applying best practices for cloud standardization and automation. Professional services can also be helpful in all three phases of the cloud migration effort. It would definitely help to have an outside perspective to provide the analysis of your applications and what will be required to ensure a smooth migration to the cloud. Then they can carry you through the scope of the project and provide the training you need for ongoing support. And speaking of ongoing support, you will need support staff in place to be trained to debug and manage your applications in the new cloud environment. Migration automation software can also be evaluated to provide a custom data migration to your cloud environment and to set up an automated disaster recovery plan as a service, for example. So after the migration is complete, how do you get the most benefits out of your Synergy application's new cloud computing environment? To maximize value, I suggest working towards an end goal of cloud automation and orchestration on the cloud through replatforming and eventually re-architecting. A foundational layer of cloud automation is ideal to help support the cloud orchestration. Automation includes not only automating your builds, your testing and deployments, but also refactoring your application to become containerized in reasonable microservices to enable the scaling that orchestration supports. And to configure your infrastructure as code. Once you have a foundation of cloud automation and have containerized your application, you can begin expanding your infrastructure as code to cloud orchestration frameworks, such as Kubernetes. These orchestration frameworks enable you to auto-scale your application automatically, both horizontally and vertically, while maximizing resilience and leveraging the latest technology. Horizontal scaling involves creating more instances of your application, and vertical scaling involves adding more hardware resources to each of your instances. So cloud automation enables your cloud administrators to automate processes to reduce the costs associated with ongoing cloud application support and management by automating the delivery of your application, your infrastructure, and providing scaling. Cloud automation can be leveraged in the software development lifecycle for testing, diagnostics, security, and versioning. Automation through containerization and configuration as code will set your team up for success with transitioning into full cloud orchestration. So if you look here, containerization tooling is valuable for hosting your application on a server optimized only for your application to maximize your hardware resources allocated for the best overall value. You're no longer having to hosting unnecessary processes or services on the same server, and it really lets you scale the things that you need the most. Containers are effectively a minimalist virtual machine for your application. Containers make it effortless for developers to spin up a development node locally using tools such as Docker. There are also containerization tools like Container that are even lighter weight than Docker to drive the underlying infrastructure for production workloads using orchestration frameworks like Kubernetes. I would definitely recommend starting with something like Docker first. Containerization ultimately sets you up for success with both optimizing your software development lifecycle and eventually your production workloads and orchestration. Infrastructure is the code, and it enables you to manage your cloud computing resources on your cloud provider directly with code using tools such as Terraform without having to fully commit to something like Kubernetes for orchestration. This enables you to create new environments for dev, stage, and production on demand to ensure consistency and best practices are followed around access control. This also enables developers to directly make infrastructure changes through a fully traceable delivery process that undergoes approval through pull requests with continuous integration and continuous deployment pipelines. If you need greater control over your IT resources, such as applying very custom configurations of bare metal servers, virtualized hosts, or network devices, and you're not ready to go into something like Kubernetes for orchestration, you could also use infrastructure as code IT automation platforms such as Red Hat's Ansible. As described by Red Hat, the Ansible automation platform provides an enterprise framework for building and operating IT automation at scale, from hybrid cloud to the edge. It's specifically for a lot of these edge cases here. But Ansible automation platform enables users across an organization to create, share, and manage automation from development and operations to security and network teams. IT managers can provide guidelines on how automation should be applied to individual development teams, and automation creators can write tasks that use existing knowledge. Ansible automation platform provides a more secure and stable foundation for deploying end-to-end automation. There's some other tools out there as well, like Chef, for example, that fill a similar need. Containerized applications using automated continuous integration and continuous deployment pipelines with Terraform to manage your cloud provider's API, and Ansible or other tools to manage the edge of all end-to-end IT operations in the cloud. Your team can set the DevOps foundation for full cloud orchestration. To give you an idea of what that could look like, you may want Terraform to spin up your VMs as you start off rehosting, and then you could use Ansible to configure your VMs exactly as you need until you're ready for containerization. A desirable end goal of cloud migration and automation is fully automated cloud orchestration. Kelsey Hightower, our keynote speaker, and other speakers like Jeff at our Dev Partner Conference have discussed the topic of orchestration in Kubernetes in more depth. So I highly suggest watching their presentations for more detailed information. Cloud orchestration maximizes the value of your resources and reduces the number of administrators needed to support your applications, as all of your virtual resources become automatically coordinated with physical resources. Cloud orchestration reduces redundancy, provides rapid horizontal plus vertical scaling, and enables failover and fallbacks. Popular orchestration tools include Kubernetes, which is leading the pack here, Docker Swarm, and OpenShift. Cloud providers also have their own orchestration services, like Azure Kubernetes Service or Amazon's Elastic Container Service, that provide more out-of-the-box tooling and integrations around Kubernetes and other orchestration frameworks. You don't have to use the cloud for orchestration frameworks, but they do work very well together to maximize your value on the cloud. Thank you all for your time today and attending business considerations when migrating Synergy apps to the cloud. We discussed an overview of what cloud computing is, the benefits of cloud computing, how to migrate your applications to the cloud, and some tools to maximize your cloud migration value. Are there any questions?
All right. Welcome back. Just as a reminder, there is a raise hand icon that you can click in the chat at the bottom. If you don't see it, if you click the bottom of the chat, you should see it in the bottom right corner there. Let's see here. So let's get in it to it. I don't see any in the chat at the moment, but so Tim, if I was going to be going to cloud provider, what do I need to use a cloud provider for orchestration?
So to use a cloud provider for orchestration, I did mention different services that each cloud provider does have. So like Azure has Azure Kubernetes Service, Amazon has the Elastic Container Service, and also Kubernetes Service. So you can choose different orchestration services on each cloud provider that do offer. They offer an ecosystem around like Kubernetes or other orchestration or just containers in general that provide easy access to installing tooling, and they manage a lot of the heavy lifting for you. So that's just one thing I would look into on each of the different providers here is what tooling that you're planning to include. Like I know in Jeff's demo, he was showing off like FSX on Lustre with AWS to enable read-write many support for RCC. So those are just some of the things that I would look for here.
Oh yeah, absolutely. We have a question from Chuck. So where do you see Rancher or Portainer in the cloud migration journey?
I would see that as more of like a Docker alternative. So I think you could definitely go that route instead. I personally like Rancher since they don't have the licensing requirement now that Docker does have. So I think those are great alternatives.
Oh yeah, awesome.
Thanks, Chuck.
Yeah, thanks for that question. So so if Synergex, if we're going to be doing we've done some cloud adoption. What does the Synergex cloud adoption look like right now?
Another good question. We've also been adopting a lot of these standards that I mentioned during the presentation. So we're looking at managing our Azure resources through more infrastructure as code, moving more of our overall build automation, where we're using similar things to automate our VM creation and our VM spin up that you might use to rehost, for example. So we are adopting a lot of these standards that I talked about today.
Yeah. And based on that, what were the challenges that you experienced while trying to adopt these best practices for the cloud?
One of the biggest challenges is if you start working in the cloud without really adopting these standards or thinking about the best practices, then there's more work for you to come back to and clean up later. So that is something that I would take a look at, is making sure you have the right guidance or you're doing the research yourself to really enable these standards up front so you don't have to tear down your resources and rebuild. And you don't want to repeat effort in this case.
Mm-hmm. I'm kind of curious. So when it comes to best practices and that kind of stuff, what did you find were the best resources? I assume there's documentation, that kind of stuff provided. Did you get any help from, the cloud platforms themselves?
Yeah, each cloud provider tends to have their own like learn or like training courses available for you. That so you could work towards certifications on specific providers. You could look at getting some professional services advice. Another thing too is if you are doing infrastructure as code as a route, there's a lot of examples out there for how other companies do their best practices. There's modules out there that are even provided by a lot of these large firms, so you can use those to help drive your direction.
Oh, absolutely, absolutely. That's great. I do have another one here from. This is actually from myself. I was kind of curious. So, a lot of people, we're kind of in the middle of, ending up a fiscal year, and a lot of people are, going to take this and get ready to do their pitches to their own executives and that kind of stuff. Be like, we need to get to the cloud. Is there anything they can be doing now to kind of get ready for that? I did see that, you talked about the replatforming, refactoring. Is there any of that they can start doing now to get ready for cloud migration?
Yeah, that's a good question. If you want to, like, it helps have a prototype or proof of concept in place if you are going to try to sell something like this to someone. So most cloud providers do offer like a free way to work with them. So if you have like a Microsoft license, like MSDN, they give you a certain amount of Azure credit. If AWS also gives you a certain amount of free resources, so you could go on to different cloud providers and you could leverage those free tiers or those dev test tiers to spin up a prototype or proof of concept and show that, hey, we can work on the cloud. And then I think once you've demonstrated that, it'd be a lot easier to sell.
Oh, absolutely. I mean, just do like a little demo of rehosting, and yeah, that's awesome. Chuck's got another one here. So, any considerations when looking to move Synergy applications to a modern CI/CD pipeline? They're slowly moving their code into Bitbucket, but still need to piece together the rest of the pipeline. Any suggestions there?
Yeah, I would definitely start on the CI side of that. So focus on the build first, making sure you can build everything. You can optimize it later, but I would just try to take your existing processes and almost use the CI side as a way to document how you're doing your build operations and anything you need. I would also include tests in that if you can. So look at like Marty and Reef's presentation for ways to improve your automated unit testing, since that'll also enable you to make more changes here with less risk. So definitely start on the CI side, and then you can work on towards the CD side. So on the actual deployments, if you are doing the CD side, I wouldn't just jump directly to prod right away. I would probably have like some sort of staging layer first as you work your way towards full CI/CD.
Awesome. Yeah, thanks for that, Chuck. I was going to say plug for Reese and Marty's presentation there for the testing, because I know for a lot of people that tends to be one of those big hurdles of just like trying to get automated testing to work and that kind of stuff. But once it's done, it sings. It's great. I love it. All right, let's see here. Chuck, any more questions? All right. Let's see here. I did have one more thing that I have to bother you about for the support stuff and retraining. Do you have any recommended debugging tools and stuff? Like when things go wrong, what's available for figuring that all out?
So this is another thing that you can start with the rehosting and then work your way towards like replatforming. Ideally, like if you did replatforming, you'd be taking advantage of like telemetry and certain features that different cloud providers are hosting for you with like Azure and application insights. But if starting off, make sure you have good logging, of course. You could look at ways to remote attach. So there are quite a few ways to debug here. I would definitely recommend having multiple environments set up in place too, so you can do a lot of testing. Like you can simulate the issue in like a staging environment where you can do full debugging versus like a release environment where you wouldn't have that same control.
Yeah, awesome. There's some really good options out there. So we have stuff in multiple clouds, and our standard is AWS. I noticed that Synergex uses Azure. Do you have any pros or cons, Azure versus AWS and all that?
That's a good question. We did look at spinning up some of our prototypes on Azure and AWS. Of course, I've used more Azure. I've used both. I've used a lot more Azure, so I have a little bit of a bias there. But we did end up doing one of our RCC demo that Jeff worked on with AWS because of FSX on Lustre. So that was for the read-write many support, and that's sort of if you want to just jump into like EKS or one of their like the container service or the Kubernetes service that's on Amazon. They already have easier for support for setting up that prototype in this case. So I'd really look at if you want to use one of those managed services and then what is involved in each of those ecosystems for those services. That's one way I would look at it. But if you don't have that need for read write many, then Azure I found is a lot easier to get started with, just because the UI is a little bit easier to work with if you're not ready to just jump fully into infrastructure as code. So I can see why you're using both, and that is like sort of like the multi-cloud that I did talk about. But you want to be careful here if you are using both. A lot of the times, what I've seen with that is because people are prototyping in different environments, and then if you start spinning up from there without having a strategy in mind for how you want to handle your multi-cloud deployments, it can get a little bit messy later. Yeah.
Awesome.
Thanks, Chuck.
I agree. Also, so awesome. Well, thanks for your time, Tim, and thank you everyone for joining us. Please join us in a few minutes for our next presentation, that Making Crusty Code Testable with our software development manager, Marty Lewis. All right. Thanks, everyone.
All right. Thank you, everyone.